proper.
Oh.
It's, my dad's better at that now. Even though, so yeah, my dad, he has a really bad memory, but he's actually noticed a decline in his memory, but it's still better than most people for his age.
Mm-hmm.
My poor mom's been going to like 20 doctor's appointments this year alone for him.
It's not fun.
No.
In my case, I know what to blame. I can just blame lupus for it and be done, but it's still a pain.
They don't know what the cause is, unfortunately.
Yeah.
I'm gonna get stuff.
Why is that not doing that? Hello.
That over my bag yet?
Oh,
Look at that.
Notice something, notice, you got it on, you see, okay, and then watch the bolt. Make it a nice steady fin. See that leg, okay, now watch this. What do you do? Yeah, flickering, right? And why if I'm flickering, the other one? You know, Yep. Yeah, think about it. We're gonna talk about it in class in a couple weeks. Y'all think about it, so you can figure out what. I did it. You did it, huh? Yeah. How close to the method did you get, Nico, at all? Gonna try and decode it? He's like, no, man, that was too hard. Alrighty. Juniors, y'all can head out whenever you're good to go. So folks at the back table, toss the stuff back in the bin so that we have focus and we can start. See y'all next week. Yeah. All right, let's go back in there. Look that for me. You about got it over there? You're such a good boy.
Do what?
It's amazing.
Uh-huh, beautiful sandwich you've made. All right, group, are we ready? Let's move on, people. So electricity charges and current. Let him sit. Make room. Well, scoot yourself over a bit. My gracious, like you own the whole couch there. Shit. I sent your mom a meme this week. Did she show you?
She told me about it. What was the name?
Yep. It said,
She said it last night.
it said, the student in your class that stands up and yells, "She said be quiet." And I was like, Bailey.
I mean, no one else says anything.
That's
And
my girl. Okay, there we go. All right, so let's move on to this lesson today. If it will go. Come on, go. We're like talking about electric circuits. By the way, if you didn't notice, I got circuits on my leggings today. Okay, electric circuits. I know I'm so weird. All right, somebody give me the definition of an electric circuit. Peyton.
Path through which charges can flow.
A complete path through which a charge can flow. Got it. So circuit diagrams use symbols to represent parts of a circuit, including a source of, Yusuf?
Electrical energy and devices that are one involved.
Yes, okay. So now earlier in earlier in lab over there, Xander was drawing, no, Lucas was drawing out, I was trying to remember who was doing it. Lucas was trying to draw out the whole diagram for the circuit we were running for the telephone. So they look kind of like this. Here you go. So in a series circuit, who can define that one? PJ?
Charge only has one path through it that it can flow through.
Right, a charge only has one path through which it can flow. So if one element stops functioning in a series circuit, Drew, the whole thing stops. Okay. Old school Christmas lights, the real old ones. They're better now, especially the LED ones, but the real old ones, if you had one bulb go out, the whole string went out. So, pardon my cough, I'm not sick anymore, it's just like a nerve thing. If you've ever seen like National Lampoon's Christmas Vacation, he searches every light bulb that he puts on that house to try and figure out why they won't turn on.
We had a miniature Christmas tree and I spent a good week going through every light bulb.
Oh, gosh, yep,
And there was 20 going through the entire tree.
wow. Did they all go out or did,
20 light bulbs went out. No,
oh,
20 were left working. I had to fix all of them.
oh, that's fun, yep. So that's a series circuit. A parallel circuit, who can define this one for me? Oh, Xander. Was that a hand? You just went up behind your hat. Okay, okay, Chloe.
Circuit, an electrical circuit with two or more.
Yeah, electrical circuit with two or more paths to which a charge can flow. So Ridley, what happens if one element stops functioning in a parallel circuit? It keeps working, right? So these are obviously gonna be better for certain things. I caught that. It said stops.
No,
Which-
the owl looks like it's plugged into itself.
Yeah, it does. Who knows? There's a lot of cables here.
Its tail is inside the wall.
I think it's bent at the wall. All right, so we're gonna look at some circuit diagrams and then I'm gonna give you some and give you some time to complete them. So a circuit diagram, here is an example. So which light bulbs are burned out in this? What do you think is representing the burned out light bulb? Lucas, okay, E. All right, that's right. And then which light bulbs are working and will light up? PJ.
A, B, C, and D.
A, B, C, and D, she says. Okay, anybody have a different guess? Wait a minute, wait, she's still thinking about it.
And F probably.
And F probably, Colin?
A, C, and F.
A, C, and F, Asher?
A, B, all of them but C.
All of them but C? What do you think, Yusuf?
A, F, C, and A.
A, F, C,
No, yeah, A, F, C.
A, F, C? Yep, Lucas? A, F, C, all right, let's see. So these guys are gonna be lighting up. All right, because it has to make a complete path. So if your charges are going this way, beep, 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 there's no path from here. So this leg of the circuit is not going to function because it can't keep going because this guy's burned out. So which ones are working but won't light up? D and B. Okay, now here's another example. Let's give it another shot. All right, which ones are burned out? That's easy, everybody. B, okay. Which ones are working and will light up, Jordan?
A, C, and F.
A, C, and F. Anybody have a different guess? Liam?
F, B, and C.
E, F, D, and C. Ah, so what matters here is which direction the current is flowing, right? Ah, okay. Does anybody else have a different guess of any kind? Yes.
F, E, D.
F, E, D, and C. So if you learned that these were the only ones that would light up, so you guys, some of you guys were looking at it as going this direction, and some of you guys were looking at it as going this direction, but in either case, it's a loop, right? You have to have your complete loop, and these guys are not in the loop,
Well, parallels is just being used multiple times.
kind of. So which light bulbs are working but will not light up? E and D. All right, you got the idea. One more example. Okay, so obviously, which ones are burned out? E and L. Okay. Which ones are working and will light up? Colin?
A, B, J, K, G, and H.
A, B, J, K, G, and H, he says. Okay. Liam?
A, B, C, D, J, K, G, H.
Okay. Yusuf?
H, D, K, J, D.
All right, let's see. All right, here we go.
Yeah.
There's your loop.
I can say what column was.
See your loop? All right. Here's another example. Obviously, our burned outs are K and H, right? What's gonna light up? All right, go for it, Bailey.
Nothing.
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 All right.
Nothing.
What do you say, Xander?
Nothing.
You say nothing as well? Anybody say anything different?
Nothing will light up.
Nothing will light up. Nothing will light up. Why will nothing light up?
It's Satan walking.
H is in the way. Okay, so I'm gonna give you a few minutes. I'm gonna give everybody a little packet of worksheets here, a little worksheets to go through. You can make an X over your burned out ones, because it's gonna tell you, instead of it being black, it'll actually say this one and this one are burned out. This one and that one are not. So that was number 4. Oh no, that was these are all new. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm gonna give you a few minutes. You can work through these, and then we're gonna go over them all, okay?
You know, LED bugs are back.
I just sucked a whole bunch of them out of here with the vacuum just freaking yesterday. I hate them. I can't get them out of here. They hide in the creases of the curtains, and it's like, you guys can just go away, never come back. They're not, if they were real waste bugs, I might like them, but they're not. There's one for Emily.
Oh.
Yep.
That's bad. What happened to evil?
Right, there you go. All right, I'm gonna give you guys a few minutes to give it a shot and see how you do.
Miss Danny,
Y'all,
there's a flow of electrons coming from the plus and the negative.
I would do them out of the negative just because that's the way the graphic is gonna show it, but truthfully, a circle's a circle, right? A loop is a loop. Yeah. Other dog. You do it. Look at that. Whopper. This is the boy. See that I have cheese? Mommy has cheese. So, they're not used to seeing you beg for things. That's not polite. You be polite.
Then,
Uh-huh.
does the current go out of the positive or negative in the battery?
The graphic I'm gonna show you is gonna show it coming out of the negative, so if that helps you.
Okay.
Oh. Wait, then it's not going on the negative, not the positive?
Yeah, just for the sake of the of the graphic, so. I have a second cheese stick, don't I?
And to see what cheese stick.
Yeah, because he's spoiled. You should not have cheese stick. I know you might. Mama has cheese, I'm not done.
Oh.
Wait, this is called dog torture.
Yeah, because you can smell it and see it.
Oh, yeah. Dog abuse. Take, oh, you failed. You failed. Down. Down. Excuse me. Wait, leave it. That dog torture form too. Pause and place. Place. Place? No. But I shall look at nothing else. It might get up and run over the fucking it. Take. Take. Go on, take. Yummy?
Did I?
You don't really believe me, huh? You're so cute right now. You're doing the Jedi mind trick, I know. No. Look at the expression. The face, look.
Oh.
Uh-huh.
And then little tail.
You did, cards coming.
I'm torturing one more time.
Well, I'm not gonna. That's
That one you might catch, because it's a little nugget.
The last one, right on the side.
Very hard to be Aussie right now.
Oh, poor baby. Poor baby.
All right,
Take it.
take it.
Yesterday there was the cutest little chihuahua, but it was actually a nice chihuahua. And
What's that?
I know, but I think it was like a puppy chihuahua because it was like extra small.
Oh,
And then they got the puppy a sock up and then it's like popped up in the hind legs and it was like the tiniest tongue was eat. It was so cute.
oh my
I just think
gosh.
it was as big as a snout because it's
I believe it.
such a small dog. You know, it's the cutest thing ever. And then we get like huskies as well, and those are
Yep.
extra cute because you can tell.
House. Hold on, please. Hold on. I don't. I don't have
There it is. Well, you know, what if I don't? My favorite movie. Flesh.
No.
Flesh.
Oh, no.
Are we getting them done? Nah, nah. Why don't we look at one? And then we'll come back. We'll pause a little bit and let you finish a couple more. Let's look at number one. Has everybody done number one?
Yeah.
Okay. So which light bulbs are burned out? Bailey?
He's burned out.
B is burned out. Okay, and which light bulbs are functioning and will light up? Milo? A, C, and F. Good job. And then the others are functioning but will not light up. And this is the way your current flows. Right? Obviously, you could make those a different direction, but that's kind of a standard there. Got it? Okay. Are we still working on 2 or does everybody have 2?
I'm still, no, I've got it.
You got it?
I started on the opposite side.
Oh,
Yeah, I started on the opposite.
let's look at 2. Okay, what's burned out for 2? Caitlin, what is C? Okay, and what's works and will light, Asher?
A, F, and C. No, A, F, E, B, D.
K, F, B, E, D. Very good. All right, and obviously we don't have any that are functional and will not light. Okay. And there's gonna be your path. Raise your hand if you're still working on C or haven't done C yet. I mean, 3, not C. Letters, numbers, 3. Are we all good for 3? Okay. So what's burned out for 3? All right, Lucas. Okay, and tell me, Lucas, what's gonna light up? AFC. Okay. Very good. And this is going to be your path. How about 4? Anybody still working on 4? No? Okay. Yusuf, what's burned out?
A.
And what will light up? Nothing. Real good. Excellent. How about 5? Anybody still working on 5? Nope. Okay, Asher?
Nothing will.
Nothing awards burned. What's burned out?
F.
F's burned out. Okay, nothing gonna work. Everybody agree? Nothing gonna work. Very good. All right. How about 6? Anybody still working on 6? Okay, who wants to give 6 a try? James, what's burned out? E. Okay, what's gonna work? AFC? Very good.
Now I can easily do it up here, but I can't do it here.
Again, do your path. There's gonna be your path. Excellent.
Oh,
All right, 7. Who wants to do 7? Emily? All right, what's burned out? D and L. Okay, what's gonna light up?
A, B, J, K, G, H.
A, B, J, K, G, H. She's got it, and you're very good. It's gonna run like that. All right, number 8. Who wants to give it a try? Who hasn't tried one yet? Liam, you wanna give it a shot? What's burned out?
C, F, and M.
C, F, and M. Okay, what's gonna light?
A, B, J, K, G, H.
Okay, A, B, J, K, G, H. There we go. And your little path will look like so. Outstanding. All right,
You have L
who?
lit up in that one, it shouldn't be lit up.
Oh, you're right. Gotta fix that one. Oh, you're right. Let me take that out before I do that later and forget it. That's a big one. Good call, Bailey. Eh, eh, eh. Go away. Yeah. Come on, come back. Ba-dum, ba-dum. Ba-dum, ba-dum. And moving on. Okay, 9. Who wants to give 9 a shot? Oh, boy. Ridley, what's burned out? G and K, like, oh, there we go. And what's gonna light up? She's got it. A, L, M, and H, and your path will go like so. Yusuf, I can see you. You don't need to stretch your craziness over there. I know, right? All right. Yusuf, since you're dying to do it for me, this last one, what's burned out?
I didn't choose right.
You guys, actually, I forgot that was coming next. Okay, so what you need to do, forgot what was coming next. So exchange with somebody next to you and make sure this diagram makes sense. Yeah,
So I read this as like 3 bulbs are broken and like 3 more, so 6 lights should light up. Is that what it's asking?
oh, so you have the question in front of me, but yeah, I think that's what it's asking. I put it down.
actually popped out half in line.
Yep. Bless you. Everybody's make sense? What do you want to share?
Well, mine, G, B, and J are dead. And
G, B, and J, okay,
And A, L, M, and.
good. All right, we got it. Okay, Trey, you did it. Good job. Little thumbs up, Brett. Yay! All right, excellent. So power and energy calculations. Okay, what is the rate at which electrical energy is converted to another form of energy? Ridley? Okay. Electrical power is going to be the rate, and it's calculated by multiplying voltage and current. So you're on the right path. So these are your little triangles for this. Remember these guys? Our little equation triangles? Oh, yeah. Yeah, here's more. So I is going to be your current, and it's in amps. R is your resistance in ohms, and then B is your voltage. P is power in watts over here. Oh boy. And we are back with the P's and the W's and the work and the watt and the whatever, right? Okay. So,
No.
yeah, she's like, not again. That'll come back in a minute. So what helps make electrical energy safe to use? What do we need to have correct, Bailey?
Wiring.
Correct wiring, yeah, correct wiring, correct fuses, circuit breakers, insulation, grounded plugs. What's a grounded plug,
One that's pseudo-ness.
Bailey?
One that touches the ground.
Yeah, it has a wire that goes into the ground, right?
Yeah, like earth ground, not flooring ground.
Yes, earth ground. And those are the plugs with, how many prongs are on those plugs? 3. You know the ones with they have the one kind of round one at the bottom?
Yeah.
That's what you need for that, okay? So those are gonna be your plugs with the grounding.
Squirrels not to get in and chew the wires,
This is true. This little guy is chowing down on this cable, and he should not be. Not a good thing. And rats will do this.
Someone.
How is it not?
No, there were squirrels that chewed.
Maybe it's not plugged in.
There were squirrels that occupied G cables.
Oh, yeah.
Have you ever seen, there was a video a couple of months ago that was making the rounds of a guy who was caught on the street, and there were down power lines all around him, and he was a kid, teenager, and he was being electrocuted, and somebody had to go in and get him. What happens if you touch a person that's actively being electrocuted?
You get one.
Right, so how do you get a person away, do you know?
Rubber gloves.
If you've got them, yeah, what if you don't, what do you do? Look,
You get an excavator.
well, not everybody has that, Drew.
You move like really quickly. and,
Yeah.
like, Tackle them.
Yeah. Yes, so if somebody is like, if somebody in your house is working on an outlet or something and they're actively getting electrocuted, sometimes you get paralyzed and you're stuck and you can't move, and that current.
Your muscles are.
Right, 'cause your muscles are, yeah, there's electricity in, so you should push that person out of the way.
That's why whenever you went to test, it's something like, okay, don't do the phone, do it the back.
Mm,
But not on your phone, but close your hands,
Nope.
and then you'll be holding the
that's a
wire.
good point too, you can squish down on it, so yeah, so if you've ever seen the video of the guy in the street though, they can't push him. So a man had to run in there and grab him, connect himself now to that circuit and drag him out. It's a very emotional video because it's like, oh my gosh, that guy's putting himself through so much pain to do that, but he's dragging that, and he's doing his best, he keeps letting go and grabbing again and gets the guy out of the.
Stand down.
No, I wouldn't do that, man. I'd feel terrible. It's an awful thing to see. All right, so what's a fuse? Who can tell me what a fuse does? Oh, Jordan, what's a fuse do?
Wait, sorry.
That's okay. Give him a second. He's got it.
Prevents overload in a circuit.
Yeah, prevents overload in a circuit. And they work by having, we usually have a very small, y'all paying attention, a very thin metal filament within them that will melt at a certain temperature, and then it will sever, it'll break, and it'll break that circuit by that piece of metal melting. Problem is, once a fuse is blown, you have to replace it. Uh-huh.
On the brand. In
The
circuit
breaker, yeah, Yusuf pointed it out right before. Good call, good call. Okay, so in A Christmas Story, we're in another Christmas movie.
Yeah.
You know, the old man goes down to the basement because a fuse is blown. They overload that tree, right? They're plugging in all the lights and it goes boom, right? And then,
He always says it.
yeah, he has to plug in the lamp, right? So it makes things spark everywhere. So he runs down to the basement and he changes a fuse. So you used to have old houses, a lot of them that, well, they all had them, if they had electricity, they had these fuse boxes, and a fuse is an actual physical thing. And once it's burned out, it's done. And a lot of fuses you'll see in your car, it's a very small glass cylinder with little metal caps on the ends. You may have seen those before, right? What's a circuit breaker do? PJ?
It's a switch that opens when the current in a socket gets too high.
Right, so it behaves like a fuse in that with the fuse, you have the filament that will melt and now it's broken, that circuit. A circuit breaker will actually, it's called tripping, right? It'll shut off the circuit for you. Anybody ever trip the breaker in your house by overloading it? Yeah, that happens if you overload it, if you plug too much in, usually a portion of your house will go out, not your whole house, but like a room or some section of the house will go out. Mhm.
You have too many heaters plugged in, it will
Yep.
also trip the breaker.
I did it during lab once with hair dryers, and I also did it once preparing to cater an event by having too many crock pots on my counter.
Yeah.
Yep, kicked the kitchen off entirely. What happens when you trip the breaker? What do you need to do, Lucas? Oh, you don't know? Yes.
You go to a garage, you need to find a switch that's on the other side.
Right, yeah, so does everybody know where their circuit breaker in their house is located? Yep, you know? It's usually on a wall somewhere, often in a basement or a garage, sometimes in like apartments and townhouses and smaller houses, they're like in a room. But they're flat on the wall in those cases, they're built in, and they have a series of switches in them. And when you have a portion of your house go out, poof, you lost your lights, you lost your electricity. So you go down to the breaker and one of those switches, like they'll all be facing this way and one will be like, and you know that's the one. Now you also want your circuit breaker when you're doing electrical work. So we had to replace the light in our laundry room on Sunday. Jason replaced it. So he has to go down to the basement and turn that breaker off so that if he's gonna work on that electrical apparatus in there, he doesn't want a circuit going through it, right? You want to turn it off. This is like a light switch does the same thing. It breaks the circuit, completes the circuit. Yes.
I purposely turned the circuit off many times
What for?
for getting revenge on something.
His answer was getting revenge on someone. Okay.
This one found out like 2 hours later, they searched everything.
Eunice, was that you? Did you do that to you? Did you do that to your brother? Okay. All right, so personal safety. What's the transfer of excess charge through a conductor to the earth, Emily? Grounding. All right. Yes, that is grounding. So this dude here, oops, go back, guy. This is kind of the stuff that the electrical, that was loud, electrical linemen will wear. What's with the boots?
They look a bit oversized.
True.
The rubber, which is a good insulator, so when you connect yourself to the ground, you're gonna be safer.
Right, okay. So like I have a friend who works for Georgia Power and she's on the engineering end. She's not a lineman. She doesn't work on the lines. She does like the engineering end of stuff. But sometimes she has to go out in the field and she has these boots. These are like the kind that they wear when they're out in the field in case you get a down wire or whatever. And they're boots, they're real thick soled boots. She calls them her ghetto blasters, but she'll wear them out into the field to keep herself safe. Yes.
Well, the boots definitely look oversized.
Yeah, they're real big. I mean, they are real big.
Like one looks super tiny. That's just perspective.
Perspective. Lucas,
Is that an explosion happening in the background?
I have no idea.
It's a fancy background.
Yeah, it's just a fancy
Yeah.
background. All right, so electrical devices. All right, devices. Electric devices. So what is the definition of electronics? All right, Lucas.
The science of using electric current to process to transmit information.
Okay, yep. The science of using electric current to transmit information. So Would a telegraph be an electronic?
Yes,
Yes. Why, Colin?
because it transmits electricity.
Transmits electricity.
Need to transmit information.
Yes, uses electricity to transmit information. So we're talking about, that's a real basic kind of electronic, right? Real basic. All right, so what's an electronic signal then? Chloe?
Information sent as patterns in a control flow.
Right, okay, information sent as patterns in a controlled flow of electrons. So when you think about that telegraph, that's exactly what that is, right? It's patterns and you're controlling the flow by whether or not you're tapping. So when you tap on that telegraph, and you can get a good look at them before you leave today, but when you press down, it's called the sender, that little paddle. When you press down on it, it completes a circuit. And then on the opposite end, you have the receiver, and that receiver is actually an electromagnet. So remember, we talked last week about solenoids in a car. When you get in and you have a starter motor problem, but you turn the key and the solenoid is an electromagnet, you can hear it go click, 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 click. That's the same click, click you're getting from a telegraph. That click, 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 click. Mhm. When you have like a dead battery, sometimes you get in your car and you turn it on and it just goes tick, 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 tick. And it's the solenoid within the starter system trying to kick off the electromagnets moving, because you're sending electricity through them and it's causing the magnet to activate and move. All right, so electronics convey what? What am I saying? What's the sentence? What do we need, Caitlin?
Information with electrical patterns called analog and digital.
Analog and digital signals. Okay. What's an analog clock look like, Bailey?
The clock up there.
Yeah, that has no
that's got
battery
the
in it.
numerals.
Yeah, one like that with hands that goes round and round. What's a digital clock? Jordan?
It's the numbers.
Yeah, right. Okay. What's an analog signal? What's an example of an analog signal? Liam?
A radio.
Radio, great example. Great. We're talking terrestrial radio, right? You go outside and you turn the little dial and it goes, whoop, 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 and then finally you can hear something. What's another example of an analog signal? I'm sure.
Smoke signals.
What now?
Smoke signals.
Smoke signal. Technically. Okay. Analog has to do with a wave, right? All right. And digital signals are different. So what's an example of a digital signal? Computer. What part of a computer?
This
Who's tapping? Quit.
Colin,
Colin. The what?
saves
Okay. Yeah. James?
Wi-Fi.
Wi-Fi can be a digital signal. All right. So what do you call smoothly varying signal produced by continuously changing voltage or current? Jordan?
Analog.
That's your analog. All right, so this is like the radio. Like Liam just gave us the example of radio, and that's a great example. So you've got this signal that is continuously changing voltage or current in a circuit. Now think back to your lab. You were squeezing and releasing and squeezing and releasing. So what kind of a signal were you producing? Use an analog signal, right? Because you were changing, right? You were changing how much, like if you squeezed harder, did you see your light bulb get brighter and brighter and brighter? All right. Now, what do we call the code that is a series of ones and zeros, Emily?
digital signal.
Digital signal, yep, and it comes in binary. All right, what's binary mean when it comes to code? Drew?
2.
1 and 0. So what is an example, like in fiber optics, how does that work? Do you know? Drew?
It's like on off of infrared light that goes really, really quickly.
Yeah, on off of light. So we talked about fiber, I think last week or the week before, but you have these tiny little, like thinner than a hair, tiny little strands of glass, and they're shooting light down it, right? And they're looking for what? Total internal refraction, right? So it's shooting down, it's bouncing through that little thin fiber, and there's a receiver at the other end, and it's detecting either light or no light. In this way, it's it would be like if you were to take the, well, not really, I was gonna say it's a bad example. This would be like you know, smoke signals in the way that there's either one or there isn't one, right? Or mirror flashes, either there is one or there isn't one. And when you think about telegraph, like, there's a little bit of this concept in the coding, right? It's either dot or dash, but really there's a third option because there's a space, there's nothing, right? But you have that option in the off on, off on.
Flashlight.
Like a flashlight, off on, right? In that case, you can change how long it's on and how long it's off, but it would be like switching a light in a room, but the tempo is constantly the same, on, off, on, off. Uh-huh.
Is that rat Jordan?
I have no idea where he's from.
Cause those are not English language.
Stop asking what that is.
It's made by
It's
AI.
AI.
Yeah,
Like, she doesn't
There
know.
are keyboards from that.
he is writing in rat language. It's called Ratese. And you need to learn it.
Does
Yeah.
Ratatouille know Ratatouille?
You know it?
Apparently, I do not know it. The rats are going to take over the world. They're going to use Ratese and we're all going to be lost.
I wonder if they will accept me as well.
Yeah, I don't know.
I know.
I don't know. I think you know Japanese.
Yeah, definitely know that.
Yeah, we've been doing a fair amount of Japanese. All right, so, all right, moving on. Vacuum tubes. Okay, what do vacuum tubes do? All right, Jordan, you find it?
Okay, yeah, I can change from AC to DC.
Okay.
And change it current from AC to DC,
Mm-hmm.
and it can increase the strength
Okay,
as well as turn it on or off.
right, okay. So these were used in old radios, old TVs, before TVs became digital. Okay, what's the website you go to when you want to watch videos? YouTube. Why is it called YouTube?
That's the name of something. Because it's YouTube. It's YouTube.
What's a tube?
Oh, the vacuum tube.
What was in old TVs? Did some of you just make this connection? So what, do you know what some people call a TV? People who think that watching TV is just like turns your mind to mush all day if you watch TV all day. You ever heard the term boob tube? It's a boob tube. You watch the boob tube all day, you turn into a boob. Like an idiot boob, not the other kind. Some people will be watching that all day. So yeah, you boob tube, because the TV was full of tubes, vacuum tubes, literal vacuum tubes. So it was called the boob tube. And that's why YouTube is YouTube, because it's your TV. You're the one, see where they, YouTubing, there you go. We actually have vacuum tubes in this house that are visible. If you're in the pub and you look on the top of the piano, they're there. Do not touch them. He will lose his mind. But you can look at them and they're directed through his stereo system because he's always fussing with things. And the man's not just a telecom junkie, but an audiophile. So if you ever have the opportunity to have him show you his, you know, that subwoofer in the pub is like this big.
Oh, yeah.
Let me just tell you, we were leaving. We were going somewhere. Okay, there's a subwoofer in this room that's hiding under that table. These giant speakers are not my favorites, but they make movies sound good, so I go find whatever, honey. And those speakers up there got added when we moved in because there had to be speakers for surround. So we were getting ready to leave one day, and he goes, oh, it's here, and runs to the front door and opens the front door. And I'm not kidding you, the box was so big. And I'm standing there dumbfounded, and he's fighting this box through the door. It barely fit, like struggling in. I'm like, what did you buy? And he goes, oh, it's a subwoofer.
Oh.
It's not just a subwoofer, it's a subwoofer. So, yeah. So anyway, the subwoofer in the pub room, that's like,
Oh, two of them?
no, those are just the regular speakers. The subwoofer is the massive thing between the piano and the game table. So, yeah, So we do have vacuum tubes there. There are also some vacuum tubes. There's an antique radio by the front door, on the chest there near the gumball machine, right? And that was my grandfather's antique radio, and it has tubes in it as well. So you may actually find some things. If you have antiques in your house, you might actually find some things with tubes still in them. They're actually really cool. They look neat. All right, what's a semiconductor? Yusuf.
It's a crystalline solid that conducts current only under certain conditions.
Yes. Okay. What does it mean to be crystalline? Anybody know what that means? Bailey. Yeah. I was gonna say you're my only current chem student. So yes, it has to do with how the molecules are organized, and like a lattice, like a crystal lattice, like Legos fit together. It would be like if you were to take 3 balls of Play-Doh and mash them together versus 3 Lego blocks and snap them together, your Lego blocks are crystalline. Your Play-Doh is not gonna make a nice lattice, right?
I like mush.
Yeah, it's just gonna be mush. Okay, so in what kind of semiconductors, the current is a flow of electrons? Yes,
In N type.
N-type, right, okay. And then in P-type, you get a positive charge flow. So in N-type, it's N stands for what, do you suppose? Negative, right. And then P is positive. All right, makes sense, right? So most modern electronic devices are controlled by what kind of components? What do we call these? Anybody know? Liam?
Solid state.
Solid state, okay. This is a little different. This is the way we're doing stuff now, and it's pretty efficient, actually. It's great. Solid state component. Whoop, didn't mean to click that one. What's a solid state component that combines an N-type and a P-type, PJ?
Diode.
Yeah, a diode. Okay. So a diode,
As that first time I read it, it was.
whoop, I keep clicking wrong. Daggone it. So that's your diode. What's the example of a diode you probably all know best? What's the easy one? Anybody know? Do you know?
LED.
LED, which is what? What's an LED? What's it stand for?
Light emitting device.
Almost.
Emitting diode.
Light emitting diode. Okay, there you go. So light emitting diode, that's a solid state component that combines N-type and P-type. So we do have over here, sucker. All right, close the box on it. I needed to bring it back out of the box. So we have our little AC/DC generator over there, right? I'll bring it back out, and it does have diodes on it. It has 2. Who got to play with it earlier? Yeah, a couple of you. So next, I think it's a week after this, maybe next week, week after next, I can't remember. We're gonna actually go through it in lab, and you guys are gonna have to tell me how it's working. But for now, you guys have the opportunity to mess with it and see if you can figure it out. But you got an LED here and an LED here. Right? And you guys will get to mess with that a little bit. Uh-huh.
I feel like, we have something like that, like where like we snap together the things that.
Oh, yeah.
Maybe you got something like that? That is a dynamo or an AC/DC generator. So what do you call a solid state component with 3 layers of semiconductors, Ridley?
Transistor.
Transistor, okay. There used to have old radios like this, transistor radios. Whoopsie. And then what's a thin slice of silicon that contains many solid states? Lucas?
Integrated circuit.
An integrated circuit. Yeah, okay. Many solid state components. All right, so semiconductors in general, when we're talking about semiconductors, they're gonna have some level of resistance, some level of conduction, right? And then you're gonna have superconductors and all kinds of other stuff. Computer, who can define a computer? All right, go for it, Chloe.
The computer is a programmable device that can store data and process it.
Okay, store data and process information. All right, so let's think for a minute. Do you remember? This is where it gets kind of crazy. Does anybody know the oldest computer?
I do.
What is it, Drew?
A mind.
Oh, mind. I mean, like an actual mechanical thing. Do you know, Asher?
God.
Nope.
God, mind.
Do you know, Asher? The oldest computer? Do you know, James?
Alan Turing.
Oh, what? Oh, what?
Alan Turing.
Kind of. Okay, so
I forget what it was called. I know it starts with an E.
it starts with an A.
Oh, A, alpha.
I'm trying to remember it.
Oh. I forgot what it was called, but it used like a bunch of tubes everywhere.
So
Awesome.
it is. Is this it? Am I getting it wrong? Yeah. So it's an analog computer.
It's like the start thing that they
Yes, yes. I had to spell it right.
Room size.
Yes, it's called the Antikythera mechanism. And you can look this up. It's pretty cool. It was actually found at the bottom of the ocean, like in a shipwreck. And it was a solar system model that's an analog computer. It's pretty cool because it was on a ship that sunk. So it's a really interesting thing. So if you want to look up something like really fascinating that we think is the oldest computer, it's the Antikythera mechanism. Antikythera was, I think, the place where they believe it was from. All right, communication devices. What do we use to make them more portable, reliable, and affordable? Emily. Microchips are tiny little things. All right, microchips are itty bitty, right? What is the name of the place in California? What's the nickname for the place where they build all the stuff?
Silicon Valley,
Silicon Valley, why?
because they use silicon.
Yeah, because remember right here, we just said in this one, that an integrated circuit is a thin slice of silicon that contains many solid state components. So there we go.
Alex and I did a project, our chemistry project, where we create characters.
Ah, yes.
On Silicon Valley.
You're a superhero. There you go. All right, so now we're going to practice. I'll have some paper. Everybody got some talk, no math, not again.
I remember something.
Let's make sure we have some paper. Pass those all the way around. There's a couple here you might need. If you have extra, just toss them on the table. Pass these around over here. Okay, pass these around over here. Okey doke. Here's your first one. What is the voltage if a resistance of 25 ohms produces a current of 250 amps or amperes? BJ's like, I thought you liked me.
No, it's not that.
Oh, wait. I will call like I always do. Sticking your hands up makes other people anxious.
If I find it. Yeah, now for you.
Yeah. Trying to find voltage, that's me. So what do we have? We have ohms and resistance. So which one of those is ohms and resistance? We don't need watts. We don't need watts, so we don't need power. See it?
I don't know where else to look.
So if you're looking, what are you looking for? You're looking for voltage, so that's B. Your second triangle is voltage, amps, and resistance. You know your amps and you know your resistance. So you need to use the second triangle on the first one.
Yes.
It says, it tells you 25 ohms, so ohms is resistance. And here's your amps. Yeah. No, they were both in this.
Oh, you exactly.
Okay.
I remember things.
Hand down. Give everybody a minute. Okay, who has an answer? Jordan.
I just got it done, that's why.
Okay, what'd you get?
1,525.
1,525, and we have a different one, Colin? 10. All right, anybody else have something different than 10? What do you have, Bailey?
625.
625. Okay, all
I
right,
have 6,250.
all right, what do you have? 6,250. Okay, so look, V equals I times R.
Oh, I didn't see the zero.
Oh,
Okay, so no, it is 65, it's 6250. I didn't see the zero. Yeah, well, right.
Oh.
there you go.
Yeah, okay, no zero. That makes sense. Alright.
Everybody see it? All right, here's a different one. What's the current produced by a voltage of 240 volts through a resistance of 0.2 ohms? By the way, what's this letter? What's the symbol for ohms? What is that?
Omega.
Omega, very good. Don't get your hands over. Anybody who puts their hand up before I ask will be the last one called on, if called on at all, because it makes people nervous and we want people to have a chance to do their work. Okay, anybody want to volunteer? Colin, 1,200. Does anybody have anything different? Everybody has 1,200. Okay, I equals V divided by R. 240 divided by 0.2. 1,200 amps. Very good. What voltage is necessary to produce a current of 200 amps through a resistance of 100 ohms? It is gonna rain. Alexa, is it gonna rain?
Oh, it was.
It might rain today. There's a 52% chance at 1 p.m.
It was sprinkling on our way.
Yeah, it was sprinkled.
Mm. I'll believe it. Okay, anybody want to volunteer it? Drew, two, what? Wait, who what?
$20.
20,000.
I almost said
20,000. Caitlin, you have something different?
So got 20,000.
She got 20,000 as well. Anybody have something different? Different. What do you have, Lucas? 3,000. Okay.
What?
He just wants a coin for answering. All right. You got 3,000? Okay. V equals I times R. All right. 200 times 100 is 20,000. Everybody see it?
Yeah.
There we go. Yay. Y'all are so smart. All right. What resistance would produce a current of 120 amps from a 6-volt battery?
You want those ones, you just cover that. Just take the, whatever you want to move on. Just like I said.
I'm tired. That's so I still smell brains cooking in the room, so I know people are still working. Okay, anybody want to volunteer an answer? Okay, Lucas. 5. Bailey.
1/20 or 0.00 0.05.
0.05. Oh, James.
20.
20. Are you James?
Yes.
Wait, what'd you say? I was about to say I need to see the pommel routine. What'd you say?
Wow.
Oh. I was gonna say I need to see the pommel routine because yours is really sweet.
When did your voice get deep?
Oh. Y'all are terrible. I love it. All righty then. Let's see what we have. Y'all are great. Okay. 6 divided by 120 is gonna give you 0.05 ohms. Very good.
You divide voltage by the current instead of dividing. You probably divided current by voltage.
Yeah, does everybody have a minute to see what they did right or wrong or not right or whatever? Right or let's say right or not right. Let's not say wrong.
You divided 6 by 100.
Oh, I forgot the decimal.
Those decimals will get you. All right, what is the current produced by a 9-volt battery flowing through a resistance of 200 ohms? Mhm. Brains are cooking. All right, anybody have a guess? Colin?
0.045.
0.045. Anybody have anything different? Drew? 22.222222. You have something different?
9/200.
9/200, which is,
Yeah.
there you go. All right, so our answer is gonna be 9 divided by 200, which is 0.00.
It's rounded.
Oh.
Yeah.
It's rounded.
Mm-hmm. Yep, round it up. So what'd you say? 0.4,
0.045.
0.0485. Yep. So there you go. Round it up. Excellent. You did it. Yay. Aren't you smart? All right. Now, who can retell me the story of Galvani, Volta, Aldini? Who can do it from last week? And I know who remembers the story. Okay, go for it.
Well, first, Galvani experimented by cutting frog legs and putting not this story. Bolted in it and he made it jumping legs. And
Mm-hmm.
then he went on Thunderstorm. He put it on the rails
Mm-hmm.
on his fence and his and right after that, last week I guessed that he would do it on Human Corpse, and I was right.
Yep.
His nephew
Did he do
his
it or
nephew did
his
it.
nephew did it, Aldini,
Very
right?
showy dude.
Right.
Donated the corpse.
Where'd the
It
corpse
was
come
a-
from?
It was a person who murdered his wife and daughter by
Who
drowning.
supposedly murdered.
Yeah.
Supposedly.
And how was he executed?
Hanged.
Ridley? He was hanged. Yep. Right. We talked about how hangings work last week. You missed this. But yeah, we talked about how execution by hanging actually works or supposed to work.
If you do it properly.
If it's done, yeah, properly. Yeah, you did. You killed somebody, right?
Look, it's either done properly and they die instantly, or they then suffocate.
Yes.
So actually, I guess it depends if you want it to be quick or slow and actually painful.
Mm-hmm.
I think I remember the story because like this guy was being executed by a hanging and it failed 3 times.
Yep.
And they let 'em
It
live.
did, yeah. So his nephew went around, his nephew Albini went around, and what do you have with him? What did he carry with him? Who remembers what he carried? Do you remember?
Battery.
Yeah, do you remember what it's called? You're right, it's a battery. Do you remember what it's called? Oh, what? Something pile, you're right. It was a voltaic pile. Okay, what was that? Who made it? Who made the voltaic pile? Volta, Alessandro Volta. And what did Volta think of Galvani? They were rivals. What? Right. Yeah, they were rivals. Aldini went around and used the device invented by his uncle's rival to bring more fame to his uncle's discovery, right?
Kind of cheating.
Not really.
It's sort of like sticking it to your enemy, I guess, if
Yeah.
nothing else. Caitlin.
It was a device meant to prove it wrong.
Yeah, meant to prove Galvani wrong, but in the end it was used. Yeah.
Which would be
Well, not
very
right,
good.
but-
So what do we get from, what kinds of things do we have now from this great feud? Yes.
A greater understanding of the neuroscience.
Mm-hmm. Yep.
As well as batteries.
And batteries. And what else do we get? We got some vocabulary for it from it too. What do we have? Do you remember? Oh,
Galvanized.
galvanized. Yep. Chloe, what was galvanized?
You shot.
Yeah, like a person can be like shocked into action. Makes perfect sense, right? And then what else do we get from it?
Galvanized metal.
Yeah.
and sinks.
And what's the other vocabulary?
Bolts.
Bolts, right? Okay.
I
Yeah.
actually saw a video where someone was trying to, it was with frog legs, so it ties in.
Yep.
But they were eating, so it was in a Japanese restaurant, and they were eating frog legs, it was a hot pot.
Soy sauce.
No, they were trying to claim that the frog was still alive and that's why you shouldn't eat animals.
Oh,
It was obviously like, the animal's dead.
yeah.
So it's like, yeah, it doesn't feel the pain, it's dead, it's just the nerves.
Yep.
And the electricity reacting from the hot.
Have you seen the ones where the squid move? So that is a thing in certain Asian restaurants where they'll give you like a very freshly dispatched squid.
And they can buy.
And they pour soy sauce on it, and the soy sauce is full of what?
Salt.
Salt. So that helps with the conduction of the activity that's going on in there, and the legs will all, and then people are like eating the
You
moving
gotta be
leg.
careful though, because they'll get stuck in your throat.
Like, you
Yeah.
can-
Oh, Lord.
Like, you can feel them.
That's gotta be. What's that?
I will ask you guys 5 trivia questions and let you go early. These are our Edison, Tesla.
Is it Star Wars trivia?
No,
Let's go.
these are our Edison, Tesla. Actually, let me ask you more than 5 because these first couple ones are easy. I'll ask you about 8. All right. Who was born during a lightning storm, Edison or Tesla? Who votes Edison? Hands. And who votes Tesla? It was Tesla. Okay. It may seem better suited for Egon Spengler. Who's that?
The guy.
Who's Egon Spengler?
The man named Egon Spengler.
Oh, it's the guy who was electrocuted.
No. How about if I give you the next name? Or Ray Stantz. Spengler and Stantz? Who are you gonna call?
Oh, God.
Ah! It may seem better suited for Egon Spengler or Ray Stantz, but Edison at one point allegedly attempted to make a machine to attract and capture what otherworldly entities? Yeah, everybody agrees on that one? Yeah, he did. So what time frame was Edison working in? What years? What do you-
Late 1800s.
Late 1800s. Okay. Interesting turn of the century. Around the turn of the century, Victorian era, so like late 1800s, very early 1900s, there was a massive societal interest in seances, the afterlife. Like, it's a thing. Everybody wanted to talk to ghosts. It became a big old deal. They had seance parties and it was a whole thing. There were a bunch of charlatans out there taking people's money, talking to their deceased relatives and whatnot. All right, what fellow inventor and entrepreneur agreed to pay Tesla $1 million for his collective patents? Okay, what's your guess?
George Westinghouse.
Okay, Westinghouse? Ridley? Westinghouse? Anybody want to guess something different? It's Westinghouse, all right. Tesla's final project in life was a weapon that he believed would end war as we know it. What was it called? Do we know, Lucas?
Tesla coil?
Not a Tesla coil, those are real cool though. Yeah,
The nuclear bomb.
nuclear bomb? No,
Oh.
it was called the death ray. You are correct. Yes, did you know that or are you just guessing because it's crazy? You knew that, yep, the death ray. Hello. All right, from his laboratory in Colorado Springs, Nikola Tesla lit 200 lamps without the use of wires from what distance?
1 meter.
1 meter, what do you think?
2 inches.
2 inches?
100 feet.
100 feet?
20 miles.
20 miles?
1 millimeter.
What are you gonna say, Lucas? What'd you say? I didn't hear your answer very well.
1 millimeter.
1 millimeter.
The distance of 100 carats.
100 carats is a great answer. 25 miles.
Okay.
100 carats.
Carrots.
About 100 carats. All right, I'll give you one more. And then when we're done, if anybody wants to attempt to decode the message, I think the message, you still have the message, Ridley?
Yeah.
Okay, Ridley still has the message. If anybody wants to attempt to decode her message, and you can come up and have a look. Actually, I'll put this over on the counter. You can have a look at it and see if you can figure it out. Because in a couple weeks, you're gonna have to tell me how it works. So, all right, Tesla created the largest man-made lightning bolt ever recorded. How long was it? Ooh, yes.
700 feet.
700 feet.
25 carats.
25 carats long.
90.
90.
75 carrots.
Okay. 25 miles. 130 feet. Pretty impressive. 130 feet. It's pretty- Ah,
Yes, it's.
what carrot? Baby carrot? Full size carrot? Tricolor? Yeah. Look at this. She's gonna challenge your carrot unit of measurement. I love it.
Yeah.
Max.
All right, I will put this AC/DC generator on the counter. If y'all want to look at it, be gentle with it. Follow the direction on the wheel for spinning. And if anybody wants to decode, let Ridley know. And I'll make sure you have the paper if you need it. Yeah. I don't know, but I'm very curious about how that works. Congrats again. We'll also leave you with
Don't let anyone take it.
They're good too.
They are good. I like it.
Yeah, they're good.
They're great.
They're not grapes.
I said they're great.
You said they're great.
Oh my god, you can't.
I want to try. Oh, okay, sure. Let's see. So I'm gonna try.
Colin, James, can I take a coin? All right.
I don't think I've ever like used this.
God.
What? I answered a bunch of questions. That's not true. That's lies. I did answer questions. Good job, sir.
Oh, yeah, I'll put Marlo's close too. if you want to. And Colin's too. It's Colin. Take it, I agree.
can have my coins.
Oh, I'll have it. Oh, there's only one. Here, you can have it.
What did it do? Repose. Yeah.
Oh, this animal. No. Can you get it? I did it. I think you can do it.
Oh, wow.
I did it too.
You did it?
I just wrote the thing on my head.
I said I can't read that. Where's Chloe? Oh. Hey, good job. There you go. You gonna try making the electric stuff work?
Why don't we keep the bolts? Where is DC? Like survival.
There.
I think someone has responded with my pencil.
Is it purple?
Yeah.
It's in the works right there. It lives over here.
DC is better than DC because it gives me a very good saving life.
Oh. We've got a lot of fun with it all. It's a daily occurrence around here. What kind of tickle is that?
It's purple and it's got like. I use it for, I'm literally, oh my god, that doesn't mean like that. You know?
You need to do a, interrogation next week, really, and find out who has your purple pencil. There you go. Go after,
Milo.
go after Milo.
Can I try
I
this?
blame Milo.
Yeah, because they don't
Yeah,
where are the mountains?
I blame Milo.
Looks so cool. Oh, yeah. Next, quarter four is a new quarter for.
Yep, it's a new quarter for us all.
Before quarter. The first quarter, I've not been with Milo. Sad.
Oh, on your team?
Yeah.
Yeah.
I noticed I'll with him.